Hello geometry, hello. This video is going to be all about angles and angle relationships, of which in geometry we have many. So we're going to start off with two really common types of angles, complementary and supplementary. Complementary, just to give you a couple examples, would be when you have two angles, not more than two, just two, and they add up to 90 degrees. They do not have to be in any way connected. It's just any two angles that would add up to 90 degrees. Two angles whose sum equals 90 degrees. Now, one of the things that will be helpful to know is how to express a complementary angle when you don't know what the actual angle is. So for instance, in this one I'm going to call it angle 1 and angle 2. So we know that angle 1 plus angle 2, we know their measures are going to add up to 90 degrees. But what if I call one of the angles x? What do I call the other angle? So if one of the angles is x, and I happen to know that together these two angles have to add up to 90 degrees, we need that x to cancel out. So you always label the other angle 90 minus x. This is going to play a big role when we start having to translate from the English into a math equation. So you can call an angle x and its complement 90 minus x. The same strategy works for supplementary. Supplementary angles are two angles who add up to 180 degrees. So I'll put a 1 and a 2 here. And again, just like with complementary, they do not have to be connected. They don't have to be adjacent. They just have to have a sum of 180. So it's two angles whose sum equals 180 degrees. Now sometimes people get these confused, so think about the alphabet. C comes before S, 90 comes before 180. So the smaller is the complementary, which is 90. The larger, S, supplementary, goes with 180. So again, we know the measure of angle 1 plus the measure of angle 2 equals 180 degrees. But when we're doing our algebraic equations, again, what if this is x? What do I call that other angle? So we know that x plus that other angle has to add up to 180 degrees. So we need the x to cancel out. So again, we're going to call the supplement 180 minus x. So again, this is going to help when we start translating from our English to math. All right? And here we go on the first example. So it asks us, angle A is a complement of angle B, and A equals 36. Now this one isn't that hard. So we know that the measure of angle A plus the measure of angle B has to equal 90 degrees because they're complementary. And they gave us, this is 36. We're trying to find the measure of angle B. So that's just going to be a nice subtraction problem. So we know that the measure of angle B will be 54 degrees. Now we start getting into a little more of a translation problem. So we have here the measure of an angle is 9 more than twice its complement. So the measure of an angle, we're going to call that x, is usually translate to equal. 9 more than means you're adding. Twice is multiplication, the complement. And remember, the complement of x we substitute with 90 minus x. So that helps us set up an equation, and we can then go through and solve this. So we're going to do it bit by bit. I'm going to start over here so I have some room. X equals 9 plus, and we're going to distribute that 2, so that's going to be 180 degrees minus 2x. So we can add 2x to both sides. So 3x equals 189. And then what you would do, so 3 goes into 18 6 times, and it goes into 9 3 times. So x would be 63. And if we had to find both angles, Since this is complementary, you would have 90 minus your 63. The complement, which is your 90 minus x, is going to equal 27 degrees. All right, so that's why you can see it's helpful to know how to write them sort of generically. Now we have the measure of one angle is 15 less than half the measurement of its supplement. So again, the measure of an angle, the angle, we're going to call it x, is equals 15 less than. So I don't know if you remember back in Algebra 1, at the end we're going to put the 15. So whatever it is, less 15, half the measurement of the supplement. So that's going to be 1/2, and the measure of the supplement now is going to be 180 minus x. So there's our equation. We set it up, and we can now start to solve. So x equals 90 minus 1/2 x minus 15. So I'll add 1/2 to the other side. That's going to give me 3/2. And then 90 minus 15 is going to give me 75. And we can then multiply both sides by the reciprocal so that we can solve for x. So put this over 1. These then cancel out. And we get that x, so 3 goes into 75 25 times. Think about 3/4 is 75 cents. And 25 times 2 is 50. So x is going to be 50, which means its supplement, 180 minus x, so the other angle is going to be, made my box already, 130 degrees. So that would be the two angles. All right? Okay, now let's do a little bit of practice. Based on the diagrams below, how would you define adjacent angles? So 5 and 6 are adjacent. I think we've already actually talked about this word. 5 and 7 are not adjacent. So remember, whatever room you're in, the adjacent room is right on the other side of you. It shares a wall. So the same thing is true with adjacent angles. They share a ray. That's why 5 and 6 are adjacent. 5 and 7 are not. They don't share one wall between them. So we have an adjacent angle. Let's give it a definition here. So adjacent angles share a common ray. It's kind of like saying it shares a wall. All right, name an angle adjacent to 8. So again, you should look, here's angle 8. What would be an angle adjacent to 8? And you have two possible answers. You could have said angle 7 or angle 9. Either would be adjacent because they're both on either side. Then our next little definition is linear pairs, which I think we've also talked about. A linear pair is exactly, it is a pair, in other words, two angles, a pair of angles that make a line. And actually, I should improve on that. It should be an adjacent pair of angles. So let me add that in here. Adjacent pair, because they need to be right next to each other. So for instance, in this diagram, I'm going to go ahead and label all these angles. An example of a linear pair would be like angle 1 and angle 2, or angle 2 and angle 3, and you could walk around angle 3 and 4, or 1 and 4. However, then you have this concept of vertical angles. Vertical angles, and I usually abbreviate vertical angles as VA because you're going to use them a lot, and it's just shorter to call them VA. So vertical angles are opposite each other. So when you have two intersecting lines, they are the non-adjacent angles. Non-adjacent angles formed by two intersecting lines. And later on, you're going to get some properties, two intersecting lines, about those. So for instance, angle 2 and angle 4, angle 2 and angle 4 are vertical angles. You can kind of think of it as they both make the V. We also have angle 1 and angle 3 are vertical angles. All right, so I'm going to go ahead and just give you the property because it's going to come up later, but it's going to be one of your biggest theorems. We're actually going to prove it later. Vertical angles are congruent, and we'll be using that property a lot. Now on this side, usually I would have you guys doing this in your groups, but I'm going to go ahead and continue this. So we want to name a pair of adjacent complementary, remember that means the C is they add up to 90 angles. They don't have to be right next to each other, but they could be. And so you actually have you might have more than one possibility in here. But we want them to be adjacent. So actually I only see one possibility that are adjacent, and that, because notice you have 15 and 75. If I add that together, that gives me 90. So these two angles here are adjacent and they add up to 90. So I would say angle SOT and angle TOP. Those are adjacent because they share a ray, they're complementary, they add up to 90. So you didn't want to use QOR because it's not adjacent to the other angle 15. Now in part B, name a pair of non-adjacent supplementary. So let's see, 75 plus 105 does add up to 180, but we don't want them to be adjacent. So you have the possibility of several possibilities here. I'm going to choose angle TOP. That'll be my 75-degree angle. And I'm going to add that to LJM over here. So I have this 105 and this 75. Together that adds up to 180. They are not adjacent, but they do add up to 180. All right, and there was more than one possibility in that one. You could have also used QOR with LJM. Again, remember that I'm using the middle letter represents your vertex, so you know what angle you're talking about. And then down here, identify the linear pairs that include angle 1. So here's angle 1. So a linear pair, let's see, we have, again, a linear pair has to be adjacent and add up to 180. So angle 2 is a linear pair with angle 1, and we have angle 4 is a linear pair, because you could have this line right here, or you could have this line right here, either one. Angle 3 is not. Now we want to find a vertical angle to angle 8. What I find sometimes helpful when you're doing that is to kind of draw, this is why highlighters or colored pencils in geometry is nice. You're going to get a lot of intersecting lines, and it's helpful to kind of identify the angle that you really want to focus on. So here's angle 8. The vertical angle has to be created by the same lines that created angle 8 and is on the opposite side. So that would be angle 5. And then it asks, are angle 6 and angle 7 a linear pair? Explain why or why not. So when we look at these, here's angle 6, here's angle 7. They are adjacent, which is required for a linear pair, but they do not make a line. So we're going to say no, angle 6 and angle 7 do not make a line. And that's it. I hope this was okay.